Hello friends, this is Dr. Anand Pai coming back with problems in 1D motion, kinematics. This problem we have taken from Karnataka CET 2022. This is a pretty easy problem starting from the definitions. Let us see that. Okay. The question goes like this: the displacement x in meters of a particle of mass m in kg moving in one dimension under the action of a force is related to time t in seconds by t is equal to root x plus 3. The displacement of the particle when its velocity is 0 will be. Let us look at it. So first of all, let us see. So t is equal to root x plus 3 and we know velocity is dx by dt. So let us differentiate this. This becomes dt is equal to root x differentiation will be 1 by 2 root x and this is constant is 0. So x dx plus 0. Right. Now if we do this, we will get dt by dx is equal to 1 by 2 root x, right? 1 by 2 root x and dx by dt would be root 2 into root x. 2 into root x. And what is given? The displacement of the particle when the velocity is 0 is asked. Okay. So if you consider 2 root x as the equation, this is similar to when you say root x, the curve is always like this. This is the root x curve. Okay. This is y is equal to root x and this is x curve. Okay, 2 root x means double this, so it will be something like this. Okay, same root but it will be double that thing. Okay, so the distance between, I'm sorry here, the distance, this distance and that distance will increase. So here, so this will be x. Okay, this will be 2 root x. Fine. So now the question is, when dx by dt is equal to 0, what is x? That means 2 root x has to be 0, means x has to be 0, right? So there's no confusion on that. There is a problem that when we get this, we get into trouble that is it the right answer or not. Okay, but when you go with the basics, when you draw the graph, all the confusions are taken out. So answer is A, which is 0. So I hope you have understood this problem, students. Any further questions is there, you can put it in the comment box and I will be answering that. All the best, students. Happy learning.